Welcome to Study Loop.
Okay, what we want to do is we want to walk through the process to be able to determine the number of moles of each of these compounds, whether they're given as a molecular mass or a formula unit. Um, and don't forget, in order to go from grams to moles or moles to grams, we need to have either the gram molecular mass or the gram formula unit of each of the substances. And so we're going to need our periodic table. So the first one we're going to do is, for this, we have 55.98 grams of CF2Cl2. Okay, so the first thing we need to do is go to the periodic table. C is carbon. So the gram atomic mass of carbon is 12.011. This is fluorine, and we have two of them, so we have to do 2 times 18.998. And then chlorine, we have two of those, so we have to multiply 2 to 35.453. So we multiply it, and then we add all of those together. We should get 120.913 grams per 1 mole of this gram molecular mass of the substance. Okay, so now we take the 55.98 grams and we multiply it. This is kind of like a conversion factor. So 1 mole to 120.913 grams. So our gram units cancel out and we're left with the moles. And so remember, this is 4 significant digits. So our answer 0.4430 moles of CF2Cl2. Okay. So that's the process that we have to do. And so the next one is we are starting with 23.6 kilograms of iron nitrate. Okay, so this kilograms, remember kilo is times 10 to the third. So let's go ahead and multiply him by 1,000 in order to put him in the correct, we need grams. So this is 23,600 grams. And now the same thing. So we go to our periodic table, we look for iron. Iron is, and we don't have any subscripts, so it's 55.845. Nitrogen is 14.007, but I have two of those, so I would have to do 2 times 14.007. And now for oxygen, though, I have 3 and 2, so I actually have 6 of those, right? So I have 6 times, so I have 6 oxygens, so I have 6 times the 15.999. And then add all of those together. We should get 179.853 grams per mole. And then we take our 23,600 grams and multiply it by the reciprocal. So this is 1 mole over 179.853 grams. Gram units cancel out, and we're left with the mole units. And we have 3 significant digits, so this is 131 moles of iron nitrate. Okay, so the next one we want to do, C, we have 0.1187 grams of C8H8 And I believe this was I8. Okay, so carbon is 12. I have 8, so I have to do 8 times 12.011. Hydrogen is 1.008, and then 8 times the iodine, which is 126. And I believe that was the compound. It was hard to read on the writing. And so add all of those together. We get 1,312.328 grams per mole. And then what we do is we take this 0.1187 grams and multiply it by the reciprocal. So this would be 1 mole over 1112.328. And this is grams, so those units cancel out. Okay, and oops, don't know. Oh, what happened here? I think my thing kind of clicked, got stuck. Sorry about that. That's 8. So this will be equal to, and this is 4 significant digits, so our answer needs to be in 4. So 1.067 times 10 to the negative 4 moles of C8H I8. Okay, very last one is calcium oxide. And so I have 195 kilograms of calcium oxide. So once again, let's change from kilograms to grams. So this would be 195,000 grams. And then calcium, go to our periodic table. Calcium is 40.078, and oxygen was the 15.999. Add those together. I believe we get 56.0077 grams per mole. Then multiply this by the conversion. If you think of that as a conversion factor, it kind of helps. 56.077, and that's 3 significant digits, so we get 3,480 moles of calcium oxide.